Okay, so we'll start with a lecture on the tensor. Uh, Tensor is actually a quite simple concept, but it's hard to put it mathematically. So, what is a tensor? A tensor is a multi-dimensional array. Like in a array, if we have any identifier and the uh, index, like we have learned in 2D arrays, we have these two boxes, and we go from I to j in a 2D platform, in a 2D platform. But in a multidimensional array, we will have many brackets like this. Oops. Yeah, many brackets like this till how many ever dimensions we need, say d. So that's what's an array, which means you include everything from one object to another and another in another, and like that, so on. So that's a tensor. Well, physically, tensors have like so-called ranks. Like the first rank tensor, or the zero rank tensor would be called as a scalar, and the first rank tensor would be called as a vector, and a second, a third rank tensor, and so on, like that. Okay, so we'll start with the concept of tensor. Okay, here we have okay, so here we have the general spherical coordinates, having this angle phi here, and the angle theta over the radial uh, variation. Okay, so these are the three spherical coordinates that we define. Same way, now in these are in spherical coordinates, and we are limiting it into a theta and an r component for uh, the angular component, and the radial component. These are the two components that we are limiting in polar coordinates or spherical coordinates. But what happens in a tensor is, in a tensor, it's the curvilinear coordinates, like here. These are x1, x2, x3 can be referred to as our x-axis, y, z, and so on, if we name a, alpha, beta, and all that. So instead of doing that, we name it as x, and in index 1, x in index 2, x in index 3. That will give us the actually the simplified version of x, y, z, and all. Same way um, in the other coordinate, we have the y1, y2, y3, y4. Same way, if we would have something like small x and small y coordinate, and big X, capital X, and capital Y, capital Z, and capital Z, small z, like that. So same way here, y1, y2, y3, y4 are the set of the other set of coordinates. Okay, so if we locate any point, we need to mention the axis, and we need to mention the indices which it refers to. We'll understand it better as we go through mathematically. Okay, so here in curvilinear coordinates, if we see, if we want to define like dx mean or dx bar, I'll define dx bar as dx, dy, dz, d alpha, d beta, and all, and that can be written as dx1, dy, dx2, dx3, dx4, and so on, like that. Same way, dy bar can be defined as dy1, dy2, dy3, dy4, dy5, and all. So that is the dx bar and dy bar. Similarly, in the x bar, if we define an index like dy1, the dy1 can be written in this form. See, dou y1 upon dou x into dx. This is quite a bit similar to the vector notation that we provide, like this is similar, okay, not the same thing, but then it's easier to understand. Yeah, the vector, okay, this is the vector, suppose, and this vector upon this vector upon the magnitude into the direction, that will give you the vector, actually the vector. This is the magnitude into the direction, magnitude into direction, like that. Same way this can be also put it, but this has a slightly different meaning, but you can understand it like that. So this dy1 can go from dy1 dou y1 upon dou x into dx, then dou y1 upon dou x2, dou x2, okay, I just forgot to write that, okay, dou x2, actually dou x2 into dy, and same way like dou y2 dou y1 upon dou x3 into d x3 and all that till the d dimensions. Same way you can write d um, same way you can write dy2 dy3 dy4 and till dyd. The d dimension tells us like the how many dimensions you want, how many ever. Okay, so d is the capital D is the dimension. Now I'll generalize this whole thing into a form like this: drn, n is the index like d1 2 3 and all, is equal to dr index m, d dou x index m, and into dxm. This is actually simple. I'll just show you how. Yeah, this is like uh, yeah, dou, if we have a dou y and any index like n, okay, like n, this can be expressed as dou y n, okay, upon dou um, x, and x can be anything, x1 x2 x3, okay, xm into dxm. Okay, this is a form of general thing. Now another thing I want to specify in this type of tensor notation is the tensor notation is actually don't we don't specify the notation, yeah. So we don't specify actually the sum or the summation sign like that, because it's all the dimensions and we can't actually make a summation sign like that. But this actually means all of the terms added, which means like this is equal to, if I say is dou